Okay, so good morning once again. Today we're going to start our new lesson on multiple linear regression. Let's first create a new project. So let's go to File, New Project, New Directory.
Sir,
Yes.
hindi po kayo nag-share ng screen.
My screen is not sharing, sorry.
Okay, thank you, sir.
Thank you. Okay, is it sharing now?
Yes po.
Okay. So File, New Project, New Project tayo, no? And then yung sa subdirectory siya, subdirectory ng, of course, let's use yung FINTSAR K32 natin, no? Yan. FINTSAR K32, open, and then directory name, let's put to multiple linear regression. Okay. Create a project as a subdirectory of FINTSAR K32. Okay. All right. Okay, open a new session, and then create project. So it will now open a new R. All right. Okay, and when you look at your, so ito na yung yung bagong project natin, multiple linear regression R project. Of course, wala pa siyang laman na files. But please go to the file that I shared with you. Okay, yung wage data file at saka yung RMD file. And then load it to the folder multiple linear regression. Okay, and if we open R now, okay, we can now see that dalawang instance ng R na yata nakabukas. Okay, let me close this. Okay, so this is now FINTSAR K32, no? Ito yung directory natin. And then number 2, multiple linear regression. So that's now our new project. Maximize ko to. And then these are the 2 files that we loaded to our project. Okay, so naka-record siya. I'm recording. Okay, kindly chat please if you were able to get it. Okay, make sure that you have the 2 files loaded to your R project because we said that this makes it a lot easier. Okay, so let's just check class get WD. Kindly check your working directory. And it should be, yan, sa akin, it's FINTSAR K32. Okay, FINTSAR K32, and then it's inside the project that I created, multiple linear regression. You should have that also. All right. Okay, so let's now open our, let me clear this. Okay, I'll open this now, the RMD file. And it will open here it will open a new RMD file. Close ko na lang to, no? And let me just minimize the outline. All right. Kindly change the date na lang. Sorry, class. May 25. Okay. Okay, so let's start with the definition of multiple linear regression. And I'm sure this is not the first time you encountered this topic because you have been exposed to several subjects in statistics. Okay. May I have just a show of hands? Who among you have had this topic in your DSI, Decision Sciences series? I know you have some subjects in DSI, DSI-litic. Could you please chat please kung you have that subject before, where you discussed multiple linear regression or simple linear regression? Okay, thank you. I'm sure everybody, no, kasi ano yan eh, required subject na yan. Okay, good. All right, so that means that hopefully hindi masyadong hindi masyadong foreign sa atin yung mga concepts. We will be focusing more on on the analysis, on the interpretation of our output. But we'll of course have a review. So multiple linear regression, aka multiple regression, okay, oftentimes they drop linear kasi ang assumption yan linear talaga. So what's this? When we want to establish a relationship between a variable of interest and other variables, we want to create a model, we want to predict the value of that variable, okay, we can use a statistical tool called multiple regression or multiple linear regression. The objective is to identify which variables, aka explanatory variables or independent variables, can best explain or predict our response variable. So yun ang gusto natin. Gusto natin malaman kung yung mga variables na ginagamit natin can explain our outcome or response variable. Alright? So ang tawag natin dito sa mga explanatory variables or predictors, it's otherwise called independent. Yung pinipredict naman natin or ina-explain natin, we call it dependent. Okay? So again, the goal is to be able to explain your variable of interest, explain it, and also to predict. Okay? We want to determine how much or what will be the value of your dependent variable given your independent variable. The method used is called ordinary least squares, OLS. And I'll explain this in a while, no, kung ano yung ibig sabihin ng ordinary least squares. Okay, take note of the word least. Hindi siya yung LIST, it's LEAST. Yung pinaka-minimum, no? And then also this word squares. All right, now the formula, okay, let me clear first. Okay, now let me introduce to you something that's called LaTeX. Okay, so let's show this first, Control C. Control V. All right, so I'll share this with you. Okay, so this class is what we call LaTeX. It's a way to write text or numerical or algebraic expressions in R. So for example, ito, kung gagamitin lang natin class yung text editor ni R Studio, mahirap. Okay, but with the LaTeX program, we can write difficult mathematical models easily. So for example, ito. Okay, nagsimula siya sa dollar, nag-end sa dollar, and then E is equal to MC squared. Okay, so yung opening niya $2, yung ending niya $2. So let's take a look at what I was telling about. Take a look at this class. So medyo nakakatakot, yung parang pag tinignan niyo parang ang hirap naman ng code na yan. And the result is this one. Okay, so this is the result. So you can write a text like this in R using this. Of course, at the onset, parang ang hirap kasi parang ang dami ng mga ano dyan, ang dami mga kailangan tandaan. But as in any skill, talagang syempre may learning curve. No? But when you get to know this more, you will see its advantage. No? And in your cases, in your outputs, group outputs, dapat yung mga equations show dapat written in LaTeX. No? Hindi pa pwede yung normal lang na pagsulat. It should be written this way. And this can only be done using LaTeX. Okay, so let me briefly explain, for example, ano yung code na to. So as I said, nagsimula sa $2 sign dito and ng $2 sign. So pag nagsimula sa ganyan, tsaka nag-end sa ganyan, yung in-between na isusulat natin, okay, that will form our LaTeX code. The spelling of LaTeX is L-A-T-E-X. Okay, so parang latex siya o latex, pero they pronounce it as LaTeX. It's pronounced as LaTeX and not latex. All right, so tingnan nyo to, class. /begin. Okay, /begin, tapos align. And then nag-end siya, /end align. Nagsimula siya sa begin aligned and then tapos sa end aligned. If you take a look at this, align na align talaga yung text natin. So you cannot make a mistake with that. So talaga naka-align siya. And then sa first line, nakalagay and y underscore I. Yung underscore dito is used for a subscript. Tingnan nyo to. Y underscore I. For example, if I remove the underscore there, tingnan nyo, y na siya. If I put the underscore, naging y small I yung underscore. No? Is equal to, okay, what's this? /beta. So pag nagsusulat tayo, if we write Greek letters, special characters, for example, oftentimes we use this slash and then beta. Okay, ito yun. No? And then this underscore again, underscore 0. So that represents this one. So /beta underscore 0 is this one. If I remove this, ano kaya mangyayari pag tinanggal ko siya? Diba? Naging word na lang, no? Naging word na beta. Okay? But if I put the slash there, it will write the Greek symbol. Tapos ito din, /beta underscore 1. Diba? So ito yun, diba? Underscore 1, beta underscore 1, and then x underscore I1. So ito dalawang yung underscore niya kasi linagyan yung sa brackets to. Diba underscore, ano yan, yung, ito yung underscore to, it means tawag nito, gagawing subscript yung character. No? And then here, plus beta 2, plus beta 3, ganun din, plus dot, yung ellipse, plus beta n, x sub n, and then here, plus epsilon underscore I. Okay, so itong first code na to, class, it refers to this one. Yan. Okay? So as I said, at the onset, medyo parang napakahirap naman intindihin yan. No? But familiarity lang ang class, kaya huwag kayong mag-ano. Kasi later on, pwedeng sa research paper nyo, sa thesis nyo, later on pag nasa field, nasa ano kayo, nasa labor market, no? Tapos you might need to come up with reports that need technical writing like this, then magagamit nyo talaga si LaTeX. In fact, you can write books out of LaTeX. Many books make use of LaTeX to write mga expressions na ganyan. It makes it really very easy. Alright, so yung iba ganun din, class. Okay, so ito yung model natin. This is the linear regression model. And this is multiple. Bakit siya multiple? Kasi, annotate natin, you have several predictors. Beta 1, beta 2, beta 3, up to beta n. So you have n variables and independent variables that we're using here in order to describe or explain our y sub I. Okay? So what's the goal of the model? The goal of the model is to define ano yung beta null, ano yung beta 1. What are these parameters? Okay? So when we now are able to define what these parameters are, and then given the x, we know the values of x, we can come up with a predicted value. So itong value na to, this is called your y hat. Sorry for the writing. Y hat yan. Y hat. That means that's the predicted value. Now, oftentimes, si predicted value at saka si actual value, hindi sila pareho. Okay? So, to make them equal, okay, kunyari, ang actual value, ang observed value is 100. Tapos, nag-model tayo ng regression, tapos ang naging value natin is 99. No? So, ito yung predicted value, ito yung actual value. So, there's a discrepancy of 1. So, 100 minus 99, that's equal to 1. This one is now your residual. Okay? So that your predicted value, your actual value is equal to your predicted value plus the residual. Diba? 100 yung actual. 99 yung predicted. Okay? To make them equal, dadagdagan natin to ng 1, diba? Plus 1. Para 100 na rin to. So that's what this means. No? Yung epsilon dito, epsilon sub I is your residual or your predictor. Ito, no? The model's error term, also known as the residuals. Okay? Your y sub I is your dependent variable. Your x's are your explanatory. The beta null in the model, that's your intercept. The beta sub n are your slope coefficients for each of the ito pala, no? Ito yung constant term. Beta 1, beta 2, beta 3, up to beta n, they are the slope coefficients. And epsilon is your residual or error term. All right. May I pause for a while? And I'm sure you have met this equation before. So is it clear so far, class? I will appreciate your feedback. Okay. We are 31 here, 32. I hope we get responses more than half, more than 60% sana. Yung iba, alam ko na medyo may problema kayo sa internet or sa computer pala, so it's okay. But sana those who have will respond. No? Okay, so sige, thank you. Clear natin muna, clear drawings and X natin. All right, so this is our multiple linear regression equation. Now, yung multiple linear regression equation na to, this one, okay, is based on certain assumptions. Yung pag-compute ng beta null, beta 1, beta 2, up to beta n, is based on certain assumptions. And those assumptions can be found here. Okay, so tingnan natin yung assumptions ng what we call the classical linear regression model. Okay? Number 1 is linearity of the data. Ano ibig sabihin ng linearity of the data? Okay. So what's our goal? Our goal is to be able to predict y or to explain y using x. So ang unang assumption natin, kailangan para if we will be able to come up with a model, dapat yung relationship ni y natin, your dependent variable, and your x, your independent variable, should be linear. Okay, so what do we mean by that? Tingnan natin ha. Magpa-plot lang ako dito. Okay, so let me run here. Okay, suppose we have this. So plinat natin si y, your dependent variable, and si x, your independent variable. Suppose the scatter plot shows this. No? Okay. So question, is there a linear relationship between y and x? Okay, answer is looks like it. No? Although may mga points dito na medyo outliers, but generally, the relationship between y and x seems to follow a linear. It seems to be linear. There seems to be a linear relationship. So much so that we can construct now a linear model. Sorry for the, hindi straight. Ang hirap, yung mouse eh. Yan. So we can now make use of the relationship between x and y to formulate a linear model. Okay, ito okay to, no? Kasi there's a linear relationship between your dependent variable and your independent variable. Now, what if ganito yung relationship nila? Magawa na naman tayo dito ng isa example. What if ganito yung relationship nila? Okay. What will happen with this one? There seems to be no correlation between x and y. Bakit? If you take a look at this class, if you get the average of y, kahit anong value ni x pareho eh. Diba? Ibig sabihin, yung x hindi niya ma-determine kung ano yung value ni y. Kasi no matter what the value of x is, ganun pa rin yung value ni y. Unlike this one, so you notice dito, if this is the value of y, okay, if this is the value of x, ang predicted value niya, ito. If this is x, ito si x, tapos ito si y, ang predicted value niya, ito. So, across x, nagbabago yung predicted values. Ito, hindi nagbabago yung predicted values. Alright? So, dito, walang linear relationship. So, this is not a good set of data where we can use regression, no? Regression to predict your y. Okay. Okay. Another example is, let's take a look at this one. Okay. Suppose we plotted yung scatter plot ni y at saka x. Tapos lumalabas na ganitong relationship nila. Okay? Andiyan ganito, no? Alright, yung green one. Okay, if I ask you, is there a linear relationship between y and x? Okay, mukhang wala, no? Unless na-split natin yung data natin. Siguro kung hanggang dito, then medyo may downward. Pero dito, medyo upward. So in this case, it doesn't make sense to make use of simple linear regression kasi mukhang quadratic yung relationship nila. It looks like a quadratic relationship. So the first assumption is that there should be linearity. Dapat may linear relationship yung y at saka si x. So ano yung pwede natin gawin? I-plot natin yung y at saka si x. Tapos tignan natin kung talagang linear ba yung yung behavior ng data ng relationship nila. Kasi pwedeng ganito, no? Pwedeng ganyan yung relationship, no? In that case, mukhang polynomial na yan. Right? Kung ganyan yung relationship nila. So you cannot use a simple or a multiple linear regression with this. Kasi hindi linear rin ang relationship. Okay? So ang unang assumption ng multiple linear regression is that the relationship between your dependent variable x and your independent variable y should be linear. Okay, take note, what I said is linear relationship ng independent variable, a dependent variable, and your independent variable. Okay, sabi natin dapat linear relationship. Now, note, I'm not saying that dapat linear relationship ng dalawang independent variable. Okay, actually, we don't want these two independent variables to be linearly related. We'll discuss this later on in yung phenomenon called multicollinearity. Kasi kung si x1 at saka si x2 correlated to each other, what will happen is that mag-aagawan sila sa pag-explain kay y. So it will now be very difficult to disentangle. Ano yung effect ni x1 kay y? Ano yung effect ni x2 kay y? If there's a strong correlation between x1 and x2. So again, repeat, gusto natin linear relationship. Linearity of the data means we want that the independent variables to be correlated with the independent variable, but not the independent variables with each other. Okay? So clear yun, please? Klaro ba yung ano natin, yung explanation dun sa unang assumption? Okay, thank you. All right. So, kung hindi linear yung relationship nila, edi huwag ka mag-linear regression, di ba? Kung yung kanina parang quadratic siya, edi mag-quadratic regression siya. Kung polynomial, maraming ups and downs, then mag-polynomial ka, di ba? So, wala namang pumipilit sa atin na mag-linear regression tayo kung hindi linear yung relationship. That's very obvious, no? So, wag mong pipilitin na mag-linear regression ka kung hindi naman linear relationship nila. Of course, that's easy to analyze if you're looking at just the effect of one variable, one x on y, isang independent variable on your dependent variable. It becomes more difficult if you have two variables. Kasi pag two variables, three-dimensional na plot yan, mahirap gawin yon. Lalo pa kung multiple, if we have 5 variables, paano mo ipa-plot yun? Paano natin makikita? We cannot do that, no? So, pag multiple linear regression, we cannot immediately say that merong linear relationship si x at saka si y. We can only do that on a per variable basis. Kunyari, y with x1, y with x2, y with x3, y with x4. But overall, yung buo, hindi natin magagawa yun. Okay, next assumption. Linearity of the parameters. Okay, ito very important to, no? What do you mean by linearity of the parameters? Yung parameters natin, class ito. These are our parameters. No? Beta null, beta 1, beta 2, beta 3, etc. Ito yung mga parameters natin. When we say linearity in parameters, it means, class, that what does this mean? Dapat, okay, let's take a look at it in this equation. No? Dapat yung mga parameters natin linear. Okay, so, case in point. Ito hindi pa pwede yan. This one. Naka-square si B. Hindi linear yan, no? So, it will be very difficult to solve this model if your parameter is squared. Ang ibig sabihin ng linear in parameter, si beta null, beta 1, beta 2 should have no exponents. No? Dapat ganyan lang sila, beta 1, beta 2, beta 3. Ito, pwede ito. No? Ito, hindi to pwede. It would be very difficult to solve that. No? Kung naka-square yung parameter or hindi rin pwedeng naka-square root. No? Si beta. Hindi pwedeng naka-log of beta. Hindi pwede yan. Or 1 over beta. Reciprocal. Hindi rin pwede yan. So the parameters should always be linear. Beta null, beta 1, beta 2, beta 3. Wala silang exponentiation, wala silang reciprocal, walang mga log, no? Etc. Okay? Again, class, let me ask you, clear ba siya? So kapag nakakita kayo ng log ng beta, okay, either you do a transformation of that. Kasi hindi siya pwedeng hindi siya pwedeng ganun. Hindi mahirap ma-solve yan. Okay? Clear? Pa-chat nga please, class, kung clear so far. Okay, good. Okay, thank you. Yan. Thank you sa mga feedback, ha? Appreciate that. Okay, good. All right. However, may however tayo dyan, ha? However, let's take a look at the next sentence natin. Okay, ito. Assumption 2 of the classical linear regression model requires the model to be linear in parameters, but not necessarily in your predictors. Take a look at this. Okay. Our y sub I is beta null plus beta 1 x squared, beta 2 log of x, beta n pwedeng 1 over x, pwede yun. So it doesn't matter kung yung ano natin, kung yung mga predictors natin, naka-log siya, naka-square root siya, naka-squared siya, naka-cube siya, naka 1 over x siya. It doesn't matter, class. Pwede yan. Pwede yan. For as long as yung parameters natin, yung beta null, beta 1, beta 2, etc. are linear, no? In particular, yung beta 1 natin, beta 2, beta 3. If they're linear, then we're good. Wala tayong magiging problema. So that's assumption number 2, no? Linear in parameters. Assumption number 3, homogeneity of variance. Ano ibig sabihin nito? Homogeneous. Ano ibig sabihin ng homogeneous? It means constant yung spread out. AKA, the term that we use here is homoskedastic. Okay? Homoskedastic. Homo means uniform. Skedasticity means yung spread out. So uniform yung pag-spread. Okay. May ginamit na term dito yung residuals. Okay. Ano yung residuals? Saan ang gagaling yan? Residuals. Okay. First, saan ang gagaling observed or actual values? Yes. Let's suppose we're interested to study hourly wage ng isang tao. Magkano ba yung kinikita niya per hour? Tapos, gusto natin ma-relate siya with, let's say, sabihin natin may studies na education is education, tapos experience, tapos gender, kunyari. So these are our predictors. We would like to determine hourly wage based on years of education niya, years of experience, gender, etc. Okay. So, we will have actually values, yung observed values, no? Yung hourly wage. Ito yung Y natin. So, where do we get the data? Well, mag-research tayo, ano? Mag-survey tayo, etc. Ilang years of education niya, ilang experience, gender niya, etc. So, we will now have values for your hourly wage. Those are called your observed or actual. Kasi paano siya nakuha? Nakuha siya by, okay, by what class? Nakuha siya by survey, no? Or by interviewing people. So meron tayong observed value. Hirap. Observed value, no? So what do we do now? Kunyari meron tayong 100 respondents, nakuha natin mga data na yan. So what we do now is to run the model using OLS, ordinary least squares. Tapos yung model na yan, may certain characteristic yan. Okay? Discuss natin mamaya kung ano yung characteristics yan. And then, once we get the model, once we get the values of your beta null, beta 1, beta 2, beta 3, etc., depending on the number of your predictors, what can we do now? We can now get the predicted value. Okay? Paano yun? Kasi kunyari, si respondent number 1, meron siyang years of education, meron siyang experience, meron siyang gender. So we will use those, okay, in order to come up with a Y value, predicted Y value, based on the parameters, no? So pag meron na tayong value ni Y na predicted, which we call Y hat, i-compare natin yan dun sa actual. Kasi di ba si observation number 1, may actual value yan. Okay? Tapos ko-compute natin yung predicted value based on the parameters na kuha natin sa model. Alright? So, yung observed value minus the predicted value, sabi natin, this is called your residual, no? Your E. And then what do we do? What we do is we plot the E. So this is the E. Pwedeng dun sa fitted value, pwedeng sa YI, or pwedeng dun sa, pwede natin i-plot yan dun sa, okay, predicted value. Or marami pang pwede natin ipag-plot yan, okay? And then, dapat, yung residuals niya, dapat, ganito yung format. Okay, ganito. Okay, take note of the residuals. No? There are two characteristics of these residuals. Number one, okay, across all values of x, constant siya. Yan, di ba? Tingnan nyo. Yung mean niya, constant. Ibig sabihin, if you take a look at this level of x, no? X kasi, at this level of the fitted value or your x, pwede rin x, no? Yung average ng residual equal kung dito yung values natin ng x. So that's what we mean by constant mean, yung residuals natin. Another thing, not only the mean, also constant yung variance niya or standard deviation. Constant variance or standard deviation, sigma squared. How do I know? At this point, here, yung level ng variance siya ito. At this point, yung level ng variance niya, ito. So it doesn't change over time, no? Over the values of x. Hindi siya nagbabago, constant siya. So, yung homogeneity of variance, ibig sabihin yan, constant mean and constant variance. Okay? Pag constant mean and constant variance yung residuals natin, we call it homoscedastic. Okay? Yung distribution niya, homoscedastic, which is okay. Kasi dapat yung residuals natin homoscedastic. Now, paano kung hindi siya homoscedastic? How does that look like? Okay? A non-homoscedastic or what we call heteroscedastic. So ano itsura ng heteroscedastic? Pag heteroscedastic, ganito. So ito yung residuals natin, E, no? And when we plot it, ano nangyayari? May trend siya. Kung may trend kasi siya, yung mean mo hindi na constant. Diba? At this level, it can be that the dito, no, sa level na to, ang mean natin ito. Dito sa level na to, ang mean natin nag-i-increase over time, tumataas na siya. No? So hindi na constant yung mean natin. And besides also, pag ganito na yung model natin, let's say pag ganito siya, meron tayong tinatawag na fanning out or fanning in. Ito yung mga residuals natin. Notice na may ganyan, no? May ganyan na pattern. So which means that your variance at this point is not the same as the variance at this point. Across the bigger values of your fitted or your x, okay, lumalaki yung variance. Okay? So, non-constant mean, non-constant yung variance. In that case, we have what we call a heteroscedastic residuals. Heterogeneous yung residuals natin. Now, that's very important. Kasi, pag yung model natin na-violate yan, ibig sabihin yan, we have to remedy that. Hindi pa pwede na, ay okay na yan, kahit ganyan yung residuals natin. Kasi that will violate the principles of classical linear regression model. So, kunyari, sa exams nyo, hindi pa pwede na hindi pa pwede na minodel nyo lang, you came up with your betas, and then tapos na yun. Hindi. You will have to diagnose your model. You will have to test whether, isa yan, ano yung distribution ng variance natin? Is it residuals natin? Is it homoscedastic or heteroscedastic? Homoscedastic, good. Okay. Heteroscedastic, bad. We have to do some intervention with that. All right. Sige. Clear so far, class? Clear yung third assumption na dapat. Okay, my question dito. Vince, kindly share your question to everybody.
Sure, I think it got clarified na rin po.
Na-clarify na? Okay, sige. All right,
Opo.
thank you. Thank you. Any other questions, class? Okay, good. Okay, so remember, class, homoscedasticity. Okay. Ibig sabihin, constant in mean, constant in variance. Heteroscedastic, usually non-constant variance. It can be constant in mean, no? Pero non-constant yung variance. Yung kaninang fanning out, okay, let me illustrate that again. Ito, no, yan. Kung ganyan yung residuals natin, ganyan. Okay. Yan, constant in mean yan eh. Kasi kahit na dito, no, yung residuals dito at this point, ang average niya, ito pa rin. Nagkaka-fanning out lang siya, no? Or fanning in, pwedeng balik reverse to. Ang hindi constant dito yung variance. At this level, ang variance ito. At this level, ang variance ito lang. Okay? So the variance is not constant. Okay, for this. So this is called heteroscedastic distribution ng residuals natin. Okay, then we have another assumption. Okay, dito na natin ilagay, no? Ito muna. Independence of residuals. Independence ng error terms. Dapat yung residuals natin, they should not be interdependent. They should not have any correlation. Kasi pag may independence, if they're not independent, then yung value na residual ko ngayon, yung value na residual ko ngayon was affected by the value last time. Which was affected by the value last time. So kung may interdependence, dun sa mga values ng residuals, may trend yan. Okay? Independence of residuals means that there is no constancy in mean. Okay? So yun yung sinasabi niyan, independence of residuals. Okay, the residuals should be independent so that walang constant yung mean dapat and constant yung variance. Okay? And then this one, yung explanatory variables are not collinear. Yan, sinasabi ko kanina. We want the dependent variable and the independent variable to be linearly correlated. But we don't want the independent variables to be related to each other. Ayaw natin yun. No? Okay? Kasi sabi natin, it would be hard put to untangle, disentangle yung variation na ine-explain ni X1, variation ni Y, independent variable natin na ine-explain ni X1, at saka yung ine-explain ni X2. Okay? So the predictor should not be highly correlated. So there's multicollinearity when two or more of the explanatory variables are highly related. So sabi natin, mahirap tong problem na to kasi it would be very difficult to disentangle which of them thus explains any shared variance with the outcome variable. Okay, also, kung highly correlated pala sila, bakit paggagamitin pareho? Kasi parang wala naman madadagdag yung isang variable in explaining the other. Since they're explaining the same thing. Very high correlation sila. Okay? With each other. If that's the case, then there might be a need to remove one of them as your predictors. Kasi sa modeling class, sa regression modeling, parsimony is key. Ano yung parsimony? Yung kuripot. No? Kung kaya mo naman palang i-model yan ng 3 variables kahit compared to 10, ba I'm just exaggerating, or 100. Bakit mo gagamitan ng 100 variables kung pwede naman palang 3 lang? Right? There's such a thing as parsimonious modeling. Number one, for practical purposes, sige, gumawa tayo ng survey na 100 variables. Kung hindi, taon-taon natin matatapos yan. Diba? It has cost implications, yung actual research, yung actual survey. May mga cost implications yan. May time implications. Diba? Imagine, nagsisurvey ka, then you have to ask for from each respondent 100 variables. Paano mo gagawin yun? Diba? Aabutin ka ng dekada na nun. Tapos ang kailangan pang respondents, 100. Tapos mag-isa ka lang. Ako, patay. Right? So, if both variables are highly correlated, they will explain the same thing dun sa dependent variable natin. So, bakit mo pa isasama yung pareho? Let's choose one. Okay, and number 6 class is normality of residuals. Okay, so normality of residuals, dapat, when we plot the residuals, dapat normally distributed siya. Okay, let's take a look at this. May references akong binigay. It's good for you to read this also. Medyo similar naman sa discussion natin ngayon, pero maganda rin yung additional information, additional learning. Okay, so this is part of what we discussed a while ago, yung key assumptions of ordinary least squares. All right? So ito yung assumption, linear in parameters. Okay. Tapos ito, random, ito hindi ko na sinama, no? Random sampling of observations. Ito, class, conditional mean should be 0. Okay, ito yung expected value ng error term given your x is equal to 0. Ito yan, no? Expected value. Ang conditional mean natin dapat 0. Okay, I'll explain this in a while, no? Alright, tapos number 4, no multicollinearity or no, lalo na perfect collinearity. Mas masahol yun. Okay, tapos yung homoscedasticity. Okay, and no autocorrelation, ito yung independence ng error terms natin. Okay, ito yung sinasabi ko kanina, the variance, no, of your error terms given your x should be constant. Okay, so if you're plotting x and the fitted value and the epsilon, the errors across several different values of x, dapat yung variance ng error term natin constant, hindi dapat nagbabago. So that's how we write your the variance should be constant. Ito yung numerical ano. All right. So ito example class, no? Okay, ito yung heteroscedastic na error distributions. Ito yung homoscedastic. Ito, the variance of your error terms is not constant. It's increasing over the larger value of the x. Ito naman finding in, no? Lumiliit yung variance niya, hindi constant. Ito constant. Constant mean, constant variance. Okay, so I leave you class to read the rest of this. And there's another reference which I want you to just explore on your own, yung pangalawa. No? Simple lang naman yan. No? Okay, so a while ago, we said that our model is supposed to be this. Ito yung model natin, di ba? Saan na siya? Ito. Yan. Y sub I is equal to beta naught plus beta 1, x1 plus beta 2, x2, etc. Okay, the question is, anong model ang ginagamit in order to compute for the parameters? We said that it's OLS, ordinary, di ba? Or mag-annotate na lang ako. Supposed to be OL, hirap. I think I need to replace my mouse. OLS, no? Ordinary least squares. Now take note, itong L na to, least, to L-E-A-S-T. Itong S na to, squares. Okay, saan nanggaling yun? So balikan natin yung ano natin dito, yung equation natin dito. Okay, sabi dito, we make use of what we call the least squares line. Okay, so how does that happen? Okay, let's start with the concept of observed and predicted. Di ba sabi natin may observed value tayo. Ito yung actual value. Ito yung value na nakuha natin through surveys. And then, di ba, we apply regression in order to come up with a model explaining your dependent variable. Tapos pag nakuha natin yung mga parameters, yung beta null, beta 1, beta 2, etc., we are able to compute for your predicted value. Ito yun. And the difference between your actual value and your predicted value is your residual. Ito. So observed minus predicted. No? Okay. Now, ulit tayo, no? Let's annotate again. Okay. Palakihan ko siya. Okay. So ito yung ano natin, no? Okay. And then ito yung y natin. Ito yung x natin. And then this is our scatter plot. And the model that we generated for this one is this one. Okay, so, sorry. Pasensya na sa drawing ko, ha. Ang hirap ng ano ng freehand sa mouse. Okay. Ano ko nga sandali. Pangit nitong black. Ang red pala. Dali, ha. Ayaw mag-ano, ha. Wait. Clear ko na nga. Okay, again, so this is our axis. Ito yung ano natin, plots. Okay, and we know that the regression line will be, andito yung maging regression line natin. Ito. Yan. Okay, so this is yung predicted value natin. Ito yung mga predicted values natin, yung mga y's ito. Ito yung actual natin. The difference between the actual and this predicted value is your residual, E. Okay? So may mga E's na malalaki, may mga E's na maliliit. Depende. Okay. Now, let me ask you, class, if I add, so some of the errors will be positive kasi mas malaki yung observed value natin kaysa predicted value. So some of the errors will be negative. Nasa baba siya ng regression line. Ibig sabihin, mas mataas yung predicted natin kaysa actual natin. Okay. Now, if we add all of this, yung mga distances na to, in-add natin yan, in-add natin to, lahat ng mga residuals, yung iba siguro eksakto, yung iba konti lang yung difference. If we add all of this, what do we get, class? We get the value equal to, answer, 0. No? So, kasi ganyan talaga yung regression. May mga values na nasa taas, may mga values na nasa baba, the regression line. But if we add everything, it will be equal to 0. So we don't actually create a model out of this kasi wala naman tayong information makukuha dito sa summation of E. So what we do is, instead of getting E, we get the sum of your residuals squared. No? Okay? So we get this, and then we'd like to minimize this. Gusto natin yung pinakamaliit na squared residuals. For example, ito. Ito, squared residuals yan. Ano? So lahat ng mga squares dyan. So the regression line is that line of best fit, where if you add all of these squared residuals, it will be the minimum. Yan. Siya yung pinakamaliit. Kaya ang tawag sa kanya, least. L-E-A-S-T. Least and then squares. Ibig sabihin, dinoble natin squared yung residuals. Okay, pause muna ako, class. Ito ba yung explanation na nakuha nyo dati? I hope it's clear, or is this something new to you? Could you please chat kung yes, na alam na namin to, or no, this is something new for you, yung squared residuals na yan. Okay. Okay, new. Okay, but same, okay. The house is divided, okay. But I hope class clear na sa inyo, ha. Familiar, new, okay. For some of you, bago siya. For some of you, na-explain na dati. So now, class, kaya siya ang tawag sa kanya, ordinary list. Yung list dito yung pinakamaliit, squares. Squares yung square ng mga residuals. Okay, which is illustrated by this box. No? Okay, parang area lang yan. Okay, and also, this is unique. Unique siya. Ano ibig sabihin ng unique? There can only be one line. That's the line of best fit. So yung values ng beta null, beta 1, beta 2, etc., they are unique. Kasi iisa lang yung regression line. Imagine pag nag-regression line ako dito. Ang lalaki ng mga errors, di ba? Imagine to. Squared ng error yan. Ito pa. Okay? So you will not get the minimum. This is only what we call sa sui generis siya, na one of a kind. So pag may data points tayo, tapos magre-regression tayo, we can generate our multiple linear regression model using ordinary least squares, and it will give us the unique value. So iisa lang ang pwedeng least regression model, regression line. Alright? So again, pause muna ako, and may I ask class kung clear yung concept na yan? Yung ordinary least squares, yung pinakamaliit na squares. Squares ng residuals natin. We don't use the sum of the errors kasi they will definitely give us equal to 0. And walang information tayo makukuha doon, no? Kung 0 lang yung residuals natin. Alright, sige, let's move on. Tuloy natin to. Okay, clear ko muna. Okay, ito yung sinasabi ko, di ba kanina? Observed minus predicted. Okay, thank you. So, the least squares line is the one that minimizes the sum of the squared residuals. Okay, so that's very important, no? Kasi, alam natin, I think ito sinabi ko dito. So, I'll explain this now. All right, so these are the properties of the least regression line. Okay, hindi lang basta-basta kahit anong line yan. Ha? Sabi natin, unique yung line na yan. And it's called that's why it's called the line of best fit. Okay, una-una, the regression line goes to the center of the mass point. Okay, ano yung center of the mass point? So, i-drawing natin. That's the first property. Okay, so you have here, okay, ito yung si Y, si X, tapos pre-not natin siya. Let's assume that this is the plot. Tapos if you get the average of Y, ito siya, no? Okay, ko na lang ibang kulay. Ito yung average ni Y. Kasi ito yung Y, tapos average yan. Sabihin natin, ito yung average ni Y. This is Y bar. Tapos si X naman, sabihin natin ang average yung somewhere here. Ito na lang, no? This is your X bar. Okay, y bar, x bar. So the regression line will always, it will always, no? It will always touch this one. Kung ano man yung regression line yan, tatama lagi yan dito sa y bar, x bar. Yeah, that's what it's saying here. The regression line goes to the center of the mass point. This is the center of the mass point. Yung coordinates na x bar, y bar. Okay? So, clear yun, class? Laging dadaan yan dyan. Laging tatama siya dyan. Okay, and then, the slope of your regression line has the same sign as the correlation coefficient. What do we mean by this? Okay, if we get the correlation between, annotate ulit tayo. So, for example, you have your correlation between x and y. Okay, correlation ng x and y. You know what correlation is, di ba? It's how the two variables move in the same direction or in a particular direction. If it's positive, then ibig sabihin, they move in the same direction and then, they move in the same direction whether paakyat or pababa. No? So, pag positive yung correlation, either pa ganyan or sorry. This is positive correlation. Okay, this is negative correlation. They move in opposite directions. Same direction, opposite direction. Okay, why opposite direction? In this case, si y, okay, lumiliit yung value. Pero sa x naman, lumalaki yung value. No? Direction x pa ganun. Si y naman pababa. Okay, so negative correlation to. So if the correlation between your dependent variable and independent variable is positive, then therefore the beta, the coefficient between the two variables will be the same, positive then. Kung negative yung correlation nila, negative din yung coefficient, yung parameter. Okay, so that's what this means. The slope has the same sign as the correlation coefficient. Okay, so what do you mean by negative correlation? Ibig sabihin, they move in opposite directions. Therefore, yung beta natin will also be negative. Kung correlation is positive, then beta should be positive. All right, so clear ulit natin. Okay. All right, third. Okay, ito yung sinabi ko kanina, no? The sum of the residuals is 0. Okay, tingnan nyo yung paano sinulat to, no? So again, $, and then $. Okay, slash sum. Okay, I use the mathematical symbol for sum. Okay, and then underscore. Medyo iba yung ano dito, ano? Underscore ito. Brackets I is equal to 1. Yung ano niya, yung subscript niya dito. Tapos yung taas niya, caret N. Ito yun. Okay, and then Greek letter / epsilon underscore I. Ito yun. Is equal to 0, close. Okay? So actually, yan. Pag click ko to, lalabas tong ano natin, to equation na to. Okay. Also, this one, the residuals and x values are uncorrelated. Okay, sandali nawala yata dito yung ano. Okay, so this should be number 3. No? The residuals and the X values are uncorrelated. We don't want the residuals and the X, the predictors, to be correlated. Kasi kung correlated siya, ibig sabihin nun, meron pang there is still this unaccounted for na galaw ni X na hindi natin nare-relate with Y. Okay? So medyo crude yung pagbigay ko ng statement, pero that will become more clear as we go along. All right. So medyo maaga tayo, ah. We still have some more minutes. Okay. So what we're going to do in the next part will be, okay, formal na tayo na gagawa ng model ng regression, no? So we will be needing some of the packages that we're going to need is psych package, pastex, OLSRR, and Stargazer. Now, I leave you, class, to look at this individually. Say, kunyari, yung psych, ano ba yung ginagawa ng psych? Okay, tingnan nyo, ah. So we go to packages. Let's have examples of packages that are very important as far as regression is concerned. Ito, tingnan nyo. Psych. Procedures for psychological, psychometric, and personality research. Psych, kunin natin to. And then description file, ano bang ginagawa nito? So pareho lang din. Okay. Description, a general purpose toolbox developed originally for personality psychometric theory and experimental psychology. Kasi sa psych class, yung statistical analysis is very important sa kanila. Pati yung even regression is very important. Functions are primarily for multivariate analysis, factor analysis, cluster analysis, reliability analysis, and descriptive statistics. Okay, sandali, may question yata. Where can we download? Di ba, you know how to download, class, di ba? Sa R nyo i-download to. Di ba yung install.packages? Okay. Di ba, class? You know already that to download packages, you use this install.packages. So, sa R nyo kukunin to. No? Alright, sige. So, ang ginagawa natin dati, di ba, install.packages. And then, di ba, how do you do this? C. Kasi marami sila. And then, di ba, psych, close quotation, and then pastex, close quotation, and then OLSRR, and then Stargazer, kalimutan ng Stargazer. Okay, so that's how you load a package. Don't run this first, no? Huwag muna natin i-run, tapos ila-library natin para sa library isa-isa. No? Library ni psych, library ni pastex, although may function na pwede tayong gamitin para automatic. Okay, sandali, may question sa inyo. Okay, sabi ni Vic dito, si psych wala nang install package. Bakit? Class, bakit? Kasi, if you go to packages, alright, Vic, bakit? Ba't mo sinabing ano? Hindi naman siya hindi siya preloaded eh. Walang install that package. Bakit, Vic?
I tried it, sir, individually install that package.
Packages, ha?
Yes, sir.
Install that
Try ko na lang ulit.
packages, hindi package, ha?
Yes,
Walang
sir.
function na install that package. It should be install that packages. Sige, try mo.
Okay na, sir.
Okay, ha? So, a careful class, yung CR is very sensitive to yung mga letters, no? Pag kinulang ng S, mag-error yan. Okay, so another way to do this, class, is using the pacman package. So, sige, tingnan natin si pacman. Okay, you may wish to install pacman, so go here and then install pacman. I will not anymore kasi meron na-install ko na siya. Okay, pacman. Access ko siya, pacman. Okay, and then andito siya, no? I'll click this package management tool. Kunin natin description. So para saan ba to? Ito yung mga authors, Tyler, Winker. Okay. Ini-import din niya si remotes package, methods, stats, utils. Okay. So description, tools to more conveniently perform tasks associated with add-on packages. So si Pacman conveniently wraps library and package related functions and names them in an intuitive and consistent fashion. So si Pacman, maganda siya pag mag-load ng packages. So let's illustrate that. First, make sure that Pacman is already installed. Install that packages muna si Pacman. And then afterwards, irarun natin to. No? So, i-run ko to. And then, tatanggalin natin yung hindi na kailangan ng sino. Itong kagandahan kay Pacman. Yeah, if I'm not mistaken, let me check. Control F, tatanggalin ko lang yung just removing the quotes dito. So, replace. Tinanggal ko lang, no? Okay, yan. Yung dito lang. Alright, so remember, this is the namespace, no? Namesake. Separate ko na lang siya. Okay, what am I doing here? I'm using the Pacman package, in particular yung pload. So there's a function called pload. Balikan natin tong si Pacman. And then may function dito yung p pacman_load. Ito. Okay, so this is used to load one or more packages. Ay, nag-error ako class, sorry. So if I run this, that will work class kahit hindi yung pa na-install package si psych, si pastex. Yung mga packages na yan, hindi pa natin na load, di ba? But you can already load that kahit hindi pa siya na no? Okay, there. Alright? So ang sabi dito, okay na siya, na-load na. Ang bilis. Yung 4 na yan, na-load na niya. So you can now make use of those packages. Check natin. Check ko kung na-load na si packages. Let me check. Kanina si psych, di ba? Hindi siya naka-check eh. Psych. Oops. PSY. Ayan, tingnan niyo class. Naka-check na si psych. When I use pload, automatically, linibrary na niya. Pastex, hindi ko pa naman linaload dyan, pastex. And yet, naka-check na siya. Alright, so we're going to make use of this. Be sure to know this kasi mabilis tong mag-load ng package. Okay? Alright, so next meeting, gagamitin natin tong wage.csv na to. Okay, let's take a look at another function, ito. Okay, bakit? Kasi usually, pag hindi natin ginagamit yung working directory natin, if we're not using an R project, we will have to define the file location. Kung asan siya sa natin, sa computer. Nasa C ba siya, anong folder, etc. But take note of this. Simple yung pag-load ng data. read_csv lang. Tapos sinasabi natin dito kung ano yung data na yun. Kasi ang data na yun, wage.csv. So if we take a look at this, di ba, read_csv lang. Okay, let's just take a look at read_csv. And, ito na naman ako class. Internal error na naman ako. Question mark, read_csv. Okay, wala na naman. Sorry, hindi ko siya mababasa, no? May internal error na naman ako. Okay. Try double. Read underscore CSV. Okay. May problema na naman tong ano ko. Okay. Never mind. Paki-check nyo na lang, class. No? And I hope it... okay. It's almost time. So dito na tayo mag-end, no? Yung read underscore CSV. But let's just try this. Itong function na to. Right. So, tingnan nyo lang din, class, kung ano ginagawa nitong read underscore CSV. So, we're creating this object called wage. Okay, and then we're using this read underscore CSV. Tapos, dinefine natin kung ano yung file na yun. Okay, we don't need to define kung ano yung file location kasi yung data na to, okay, it's already loaded in the R project, in the folder that we're using for the R project. So that's why this is another reason why it's best to work in an R project. Tapos ando doon yung mga files yun. It makes simple the accessing of data. All right, column names is equal to 2. Let's run this. And automatic, oops. Okay, could not find function read underscore CSV kasi dapat tong read underscore CSV dapat nasa tidyverse siya. So i-load ko muna si tidyverse. Okay. Once I'm able to load tidyverse, then yan, nasa ano siya? Nasa read R din, no? Halagay ba dito? Okay. So, but it's already loaded here. Okay. So, run ko ulit to. Okay. Magra-run na yan kasi na-load ko na yung ano. Yan, there. Plus. And you can now see that there's an object here. Wage object. So, na-load na natin si wage object. If I click this, it's the same as view, above view. And then you have now your data, education, experience, tenure, race, gender, zero status, number of dependents, and hourly wage. So this is the data that we're going to work on Monday. Now, my assignment kayo, class, but it's not to be submitted. Ano yung assignment nyo? Kindly please read on how to create descriptive statistics. Ito, performing descriptive statistics. Ano yung mga codes na pwede natin gamitin for this data, yung wage data, para malaman natin ano ba yung mga descriptive statistics. Siyempre, andyan yung mga plot, yung normal plots nila, yung mga distribution, yung measure ng mean, median, mode, etc. So your assignment is to research on how, given this data with several variables, kaya ano bang class to? No? Class, wage, I know this should be a data frame, no? So data frame siya. Okay? So next meeting, I'll ask questions about this, yung pag-generate ng descriptive statistics. All right? All right. So sige, class. I'll stop recording.